Yeah. Hey guys, let me just first check if this is fine. Okay. Yeah. Hi guys. I hope you're all well. I felt like I noticed that I skipped the higher derivative before I moved to this the application of differentiation. I don't understand why you did not like remind me that. Yes, but then it's fine. So today I will do the higher derivatives. Okay. Yeah, ever since I started teaching you, we've been finding the derivative, the first order derivative. This means we've been differentiating the function once. Okay, so today I will teach you how to differentiate the function more than once, like differentiate it for the second time, the third time. Yeah. So again, if we differentiate a function twice, we call that a second derivative. And if you differentiate it three times, we call that a third derivative, four times a fourth derivative, and so on. Okay, these are the notation that we are going to use. Okay, notation. Okay, for a first order, you know this one. We've been doing this one. df over dx, meaning we're differentiating a function of f with respect to x. Or again, we can use f prime at x. This still means the same thing, differentiating a differentiating f with respect to x. Because remember, this prime stands for the derivative. Okay, then we have the second order or second derivative. We'll have second order. Okay, that's will represent it as d of dx of df of dx. Okay, this means we are differentiating the first derivative. Okay, because now we're differentiating for the second time. To get the first derivative, you differentiate the function, the given function. Let's say you are given f. So you differentiate the function of f. Then to get the second derivative, you now have to differentiate the first derivative, meaning now we differentiate f prime to get f prime prime. Okay, and this equals to d squared f of dx squared. Okay, and this is the same thing as f prime prime. Since, okay, whenever you see double prime, this means that is a second derivative. Okay, then as for the third derivative, it will be the derivative of the second derivative. The derivative of the second derivative. And you said that the second derivative is d squared f of dx squared. And this equals to d cubed f of dx x cubed. And this is the triple prime of x. So this, whenever you see three primes, that means that is the third derivative, and so on. For a fourth derivative, you'll have to differentiate the third derivative to get the fourth order. Then to get the fifth derivative, you differentiate the fourth derivative, then and so on. To get the nth order derivative, you'll have to differentiate the n minus 1 order. Okay, that's how you find the derivative. Okay, the reason we are studying this derivative is because they will help you determine or confirm the maximum or the minimum points for any function. Like it will help you determine the points where the profit is at maximum or minimum. Like, okay, remember we said the aim of this module is to help you, okay, for a business, it will help you determine whether you can make profit or not, right? Or like when is the revenue higher, when is the cost, yeah, just to determine those. Then when we find the derivative, remember I said learning this higher order derivative, it will help you determine the minimum or maximum point. So this simply means it will help you determine when can you make the profits in your business, right? Let's say you are selling phones, right? It will help you decide how many phones can you sell to make a maximum profit, right? And how many can you sell to make the minimum profits? Yes. Okay, let's do an example on finding the second, third, and fourth derivative. Suppose you are given a function f at x equals to x to the power 4 plus 10x cubed plus 2x plus e to the power x plus ln x. Okay, and you are asked to find, let's say, the fourth order derivative. Differentiates, meaning you have to differentiate this function 4 times. But for you to find the fourth order, you first have to find the first derivative, then you find the second derivative, then you find the third derivative, then the fourth derivative. Remember, I said the fourth derivative is, you'll find the fourth derivative by differentiating the third derivative, the third order. Then to get the third order, you need to differentiate the second order derivative. To get the second order, you need to differentiate the first order derivative, right? Oh, and again, one thing I forgot to mention, remember those rules we've been doing, the rules of differentiation. We're still going to apply them here. We're still using the same rules, like the rules that I gave you, the power rule, the product rule, the quotient rule, the chain rule. Again, here, it depends how is your function. If your function is a product of 2 terms, you're still going to use the product rule. Doesn't matter whether you are asked to differentiate it to find the fourth derivative or the first derivative. The same rules still apply. Okay, let's do this. Okay, we said to get to this fourth derivative, we need to first find the first derivative, meaning we need to find, oh, then there comes my pen. Doesn't work again. God. Wait just a second. Okay, I guess it doesn't like me anymore. Just a second. Thank God. Right, let's do this. We first have to find the first order, meaning f prime, right? Okay. We are differentiating x to the power 4 plus 10x cubed plus 2x plus e to the power x plus ln x. Remember, the first thing that you need to do if you are given a function like this is to separate this function. Okay, meaning we can separate like this. We want x to the power 4 prime, right? This prime stands for I'm differentiating x to the power 4. Then plus, okay, I take out the constant. 10 times x to the power 3, x to the power 3 prime. Remember, you don't have to write these steps. I have to write it because I need to show you how to get to the final answer, right? But the more you do more exercises, you won't have to write all the steps. You'll know how to get to the final answer. And remember, we are writing a multiple choice. You just have to select the final answer. But right now, I need to show you how do I get to the final answer. That's why I'm doing step by steps. Plus 2 times x prime plus e to the power x prime plus ln x prime. Okay. First, we need to find the derivative of x to the power 4. Right. We have x to the power 4. You go back to the rules and check which rule can you apply here on x to the power 4. Remember, we did the power rule. And this x to the power 4 is in the form of that function that we differentiated using the power rule, meaning we have to apply the power rule here. Have x to the power 4. If you apply the power rule here, you will have 4x cubed, right? Plus 10 times. Again, you have x cubed. You need to apply the power rule again. If you apply the power rule on x cubed, it would be 3x squared, right? Plus 2, differentiating x, again, it's the power rule. If you apply the power rule, then you will have 1, because you have 1 times x to the power 1 minus 1. Okay, let me just write everything. 1 times x to the power 1 minus 1. And you know that 1 minus 1 is 0. So we have x to the power 0. And we said x to the power 0 is equal to 1. So that means we have 1 times 1, which is 1. Okay. Then plus, if you differentiate e to the power x, you will get e to the power x. Remember, it's get the same functions, comes back as it is. So it's plus e to the power x. But if you differentiate ln x, what do we get? We get 1 over x, right? So it's plus 1 over x. And then the next step is to simplify everything. If you simplify this, you'll have 4x cubed. 10 times 3x squared, it's plus 30x squared. We said here it's 1. So we have 1 times 2, which is just 2 plus 2 plus e to the power x plus 1 over x. Okay, you see, from here, we cannot simplify it further. So this is your first order derivative. But remember, we're not asked to find the first order derivative. We're asked to find the fourth order. So the next step is to find the second derivative. And we'll find the second derivative by differentiating this answer. So, okay, f prime prime of x is equal to 4 times x cubed prime plus 30 times x squared prime plus 2 prime plus e to the power x prime plus 1 over x prime, right? Okay. Again, you go back to your rules. Differentiate x cubed. You will have 3x squared. Differentiate x squared, you'll have 2x. Then you differentiate 2. Remember, 2 is a constant, and the derivative of a constant is 0. So there is no need for us to add plus 0. Okay, we'll skip that part. Then plus, again, you differentiate e to the power x. If you differentiate e to the power x, it comes back as it is. So we have plus e to the power x, right? Then you differentiate 1 over x, right? Okay. if you differentiate 1 over x, which rule can you use there? Can use a power rule, right? And you can use a quotient rule again, because it's 1 over a function. You have it denominator and the numerator. But then again, you can write 1 over x as x to the power minus 1, and then you use the power rule. I prefer to use the power rule because the power rule is the easiest rule. And if you use the power rule there, you'll have, because it's x to the power minus 1, you'll have minus 2 over x squared. Okay. Then you simplify. If you simplify this, you'll have 12x squared plus 60x plus e to the power x minus 2 over x squared. And this is the second derivative. Remember, we still want the fourth. So we need to differentiate this to get the third, then we differentiate the third to get the fourth. All right, let's do this. F prime of x. It should be 12 times x squared prime plus 60 x prime plus e to the power x prime minus 2 over x squared prime. Okay, we do the derivation. We'll have 12 times 2x plus 60 times 1 plus e to the power x. Okay, then now we differentiate 2 over x squared. If you differentiate that, you'll have plus 6 over x cubed, right? Then you simplify. If you simplify, you'll have 24x plus 60 plus e to the power x plus 6 over x cubed. And this is the third order derivative. Then we are one more step, the fourth order, what we asked for. Okay. The fourth order will be equal to 24 times x prime plus 60 prime plus e to the power x prime plus 6 over x cubed prime. Then you do the derivation. Okay, if you differentiate x prime, x, you get 1. So we have 24 times 1. If you differentiate 60, 60 is a constant. The derivative of a constant is 0. So there's no need for us to write plus 0. So we have this. Then you differentiate e to the power x, you get e to the power x. So it's plus e to the power x. Then again, you differentiate 6 over x cubed. 6 over x cubed will give you minus 24 over x to the power 4. Then you simplify. If you simplify this, you'll have 24 plus e to the power x minus 24 over x to the power 4. And this is your fourth order derivative, the one that we asked for. Okay. Yeah. Yeah, if I suggest after doing this example, you can do more exercises on your study guides and more examples. But then you will still going to have the tutorial session where you'll be asking questions based on this video. Yeah, okay. Let's move on. The next section is optimization of function in one variable. Okay, we have optimization of functions in one variable. Okay, optimization of function. This is just the process of finding the maximum and the minimum points, right? Okay, remember I said the reason we are studying higher order derivative is because they will help you identify or confirm the maximum points, right? Then now we are doing the optimization of function, which is just the process of finding those points, those maximum and minimum. Okay. And here in a function, we call those points stationary points, the maximum and the minimum points, right? Okay, suppose you are given a curve. Let's say you have these points, right? And I said stationary points are the maximum point and the minimum point. You see, if you see this graph here, this is your maximum point, it's the turning point, and this is your minimum point. Okay, let me call this maximum point A, and then let me call this maximum point B, right? You see, here the graph is increasing from this point, from this side up to A, right? So we'll say the graph is positive here, but here you see the graph is decreasing from this A to B, right? We'll say the graph is negative. Okay, we call it B. But you see from B to the positive infinity, the graph is increasing again. So call this graph this side the positive side, right? Okay, at A, the slope changes from positive to negative. You see, because from here we were positive until here, but from here to here we are decreasing again. So this means the slope is changing. It's changing from positive to negative. Then when we move from here to here, from B to positive infinity, the slope again is changing from negative, because we were from negative to positive, right? But before we move from positive to negative, right, we must reach zero. Okay, because let's say here our number, we have the positive side here, say we have 1, 2, 3. This side we have -1, -2, -3, right? When we move from this side, the negative, before we reach the positive, we have to reach zero first, right? Since the slope is moving from positive to negative, this means this part here, the slope is 0, right? And then if we are moving from positive to negative, before we reach the negative, we have to reach 0, meaning the slope is 0 here. Okay, remember, on the previous sessions, the slope was introduced as the gradient, right? Okay, so say slope equals to f prime of x. Remember, f prime is the derivative, which is the gradient, is equal to df over dx, right? Okay, remember I said optimization is just the process of finding the maximum point and the minimum points, right? And I said these are the maximum and the minimum points, right? And again, I said here the slope is 0. So how do we find these points where the slope is 0? Okay, let's say you are given a function f of x. So find these points. You can just, okay, remember 2 things. These points are when the slope is 0. The slope is the gradient. right? You are given a function f at x, and you are asked to find these points. These points are when the slope is 0. So to find these points, you can just differentiate the function that you are given and equate the derivative to 0. Then you'll be able to find these points. Just 3 steps. First, you find the derivative of the function. Then, after finding the derivative of that function, you equate the derivative to 0, and then you solve for the x values there. And then the next step will be to find the corresponding y value of that function. And that's simple. You can just take that x that you obtained and substitute it back to the function. Okay. You'll find x from equating the derivative to 0, right? But when you want to find the corresponding value of x, do not substitute that value back to the derivative, because you'll always get 0, because we said those points are when the derivative is 0. So you don't have to substitute them back here. To find the corresponding y value, you just have to take those points and substitute them back to the original equation. But let's do an example just to have a picture of what I'm saying. Okay, suppose you are given f of x equals to x squared minus 100x plus 50, and you are asked to find the stationary points, meaning the turning points, these points, right? And I said these points are when the slope is 0. Like, what is the slope? The slope is the first derivative, or is the gradient. Okay, so we need to find the slope. The slope is the gradient, so we need to differentiate this function. If you differentiate this function, you'll have 2x minus 100, right? Okay. Remember, we don't want the gradient, we want the points, right? So you just have to equate this gradient to 0. Okay, f prime x equals to 0. This means we have 2x minus 100, right? 2x minus 100 equals to 0. Then you solve for x, okay? If you solve for x here, you'll have 2x equals to 100. You divide by 2 on both sides. If you divide by 2 on both sides, you'll have x equals to 50, right? X equals to 50. Okay, I'll call this x star. This is the x value of the turning point. This points. It's either this or this, right? Between the two. Then if you're asked to find the x value, you can just leave it like that. But if you're asked to find the coordinates of the turning point or the stationary points, right? The next step is to find the corresponding value of this. But to find the corresponding value of this, you need to take this back to the original equation. Okay, this was the original equation. So where there is x, you need to substitute x with 50. Okay, that means you'll have f prime of 50, which is 50 squared minus 100 times 50 plus 50. Okay, we have 50 squared, that is 2,500. We have 100 times 50, that is 5,000. We have plus 50. If you sum that up, you will have minus 2,450. That means we have 50 is 2 minus 2,450, and this is our stationary point. Okay, sometimes a function will have more stationary point, will have more, like here in this function we have 2, right? But on the one we were solving, we find 1. Sometimes you'll have 1, sometimes you'll have 3, It doesn't matter. It depends on the session or on the function, on the form of the function. Okay. Then the next section would be to find the nature of the point. Remember, we have the maximum and the minimum point. But here I showed you how to find that point. Then the next step is to determine whether that point is a maximum on the minimum. That's where the higher order derivative comes in. Remember, I said the higher order derivative will help you identify the maximum on the minimum point. Okay. Here are the two rules that you need to know on the nature of the turning point. Okay. The nature of a stationary points. Okay. If the second order derivative of that point is less than 0, then that point is the maximum point, right? And if the second order derivative of that stationary point, the one that we obtained here, if it's greater than 0, if it's greater than 0, then that point, we say that point is the minimum point. Okay, let's go back to our example, right? These are our points. This is the point that we obtained, right? Okay, then the next step is to determine whether this point is the minimum point or the maximum point. Okay, remember I said if the derivative, the second order derivative is less than 0, then that point is a maximum point. If it's greater than 0, then that point is the minimum point. But how do we find the second order derivative? Remember, I said to get the second order derivative, we need to differentiate the first order, and we do have the first order derivative. Remember, to get the point, we need to differentiate first. So we have the first order derivative already. So you can just differentiate this first order and get the second order and check the sign. If you substitute that point, what do we get? Is it positive or negative? If it's negative, that is a maximum point. If it's positive, that is a minimum point. Okay. This is our first order. We differentiate this. Okay, we have first order is f prime of x equals to is 2x minus 100, right? 2x minus 100. Okay. What is the second order derivative here of 2x minus 100? If you differentiate this, you will have 2. Okay, we just have 2. 2 is positive, right? So this means, okay, because our point was 50. So this means f prime of 50 is equal to 2. 2 is positive. So from here, from this information, we can conclude that x star equals to 50. That is a minimum point. It's a minimum stationary point. So if this function was a profit function, that means for you to produce a minimum profit, you'll have to produce or to sell 50 products. Let's say again you are selling scones. So for you to produce a minimum profit, you'll have to produce and sell 50 scones. Yes. Yeah. Then the next section would be the interval along which a function is increasing or decreasing. Okay. we were finding the minimum or the maximum point. Remember, I said here, on this function, if you have a function like this, and this is the maximum point, and this is the minimum point, from here to here, the function is decreasing. From here to here, the function is increasing. From here to here, the function is increasing. But how do you find those intervals? Okay, you know that this is the maximum, this is the minimum, right? Try and plot those on the new axis, and then since this is the maximum and this is the minimum, for you to get to the minimum, your function must be decreasing. So this means from here to here, you have a decreasing interval. From here to here and from here to here, those are your increasing interval. Okay, suppose we have something like this. We have a function, maybe like this. Okay, and let's say you have -2 here. Okay, this is 0. Let's say this is 3. And so on. Here we have 3. Here we have -2. So if they said determine the interval where this function is increasing and where this function is decreasing. You see from here to here, it's decreasing. So this function is decreasing between -2 and 3. This is decreasing, right? And as for increasing, you see it's increasing from this side up to this side. This side, you don't know the numbers this side, but you know this side, the numbers are going to negative infinity. So you can say from negative infinity to 2, the graph is increasing. Again, from here to positive infinity, the graph is increasing. So it's from 3 to positive infinity, the graph is increasing again. Yeah, that's all. Yeah, please in your spare time, try and solve this function. F at x equals to x squared minus 100x plus 15, and f at x equals to 1/3 x cubed minus 2x squared minus 5x plus 10. Okay, on these two functions, try and find the fractional points and find the maximum, determine the nature of that fractional point. Which one is maximum, is the minimum point, which one is the maximum point, and determine where these two functions are increasing or decreasing. Okay, that's where we'll start on our tutorial session on Wednesday. Okay, we should end here. I must stop recording.